Hello, we are live. Welcome, folks, to another episode of the Platformers Community live stream. And we're starting with a special guest, Ofir Cohen. He's from Wiz, a CTO of Container Security. And that will give you a hint of what will be the topic for today, as we have many live streams showing you and learning, so you can learn from the experts in the field on how to build platforms. And in platforms, the topic that comes up a lot is security, and we'll be talking about Kubernetes and access to those Kubernetes clusters. And stick around because we'll be covering three cloud providers on how they deal with their management Kubernetes clusters, and then what platform teams need to be aware when they configure access. And we brought in an expert from the community also that have given talks around CNCF and Kubernetes meetups recently around this topic. So I want to join for everybody to welcome Ofir Cohen. And Ofir, give us a bit introduction of what do you do on Wiz, and what is Wiz also.
Thank you very much.
Thank you very much, Carlos. I'm excited and happy to be here. Thank you for having me. I work at Wiz. I'm the CTO of Container Security in the CTO office. Wiz is a cloud-native security solution that covers everything from the entire software development lifecycle. So everything from protecting your code in the IDE, in the CI/CD, later at runtime. We started with Wiz Cloud as an agentless solution that we had the Log4j moment where Wiz proved that agentless is the way to go to scale with vulnerabilities. And even before you had the notion of SBOM, Wiz was there to prove the validation and product market fit. And then we expanded with Wiz Code to the left towards the platform teams and GitHub and VCS connectors, and then to the right with the recent acquisition of Gem, where we have the SOC, IR, and more incident response and runtime protection and forensics collection, etc., etc.
Yeah, Wiz is a good partner of many cloud providers also, and outside Kubernetes, right? It does security across the board in your platform. So I'm super happy to have you, an expert that have experience both from your background. I think you have some slides. Let's put the slides up, Guy, and we'll cover a little bit about your background here.
Perfect. Okay, so on the agenda today, we're going to discuss how to secure the Kubernetes control plane. We'll start with the motivation and why we're even discussing about that. Then we'll go on and show a demo on an EKS. And by the way, as Carlos mentioned, we're going to cover the managed Kubernetes cloud providers. Of course, there is on-prem and there's OpenShift and all other kinds of different Kubernetes flavors, but for the sake of brevity, we're focusing only on managed for this talk. Finally, we're going to wrap up and explain that it's not just about hardening the control plane. Container security is a big topic, and it's challenging to cover everything. So I started presenting myself. I'm the CTO of Container Security. At Wiz, we're working with more than 40% of the Fortune 100. So my goal is, as a product manager expert in the CTO team, is to meet with customers and help designing features that assist Wiz in deploying at scale and ensuring that the product meets all of the customers' expectations and it's scalable. My main background is software engineering. I've been doing cloud native for the past 3 years. And I'm very interested in Kubernetes networking, authentication, and authorization. The reason, by the way, I picked this topic is because I felt from a personal place that it's very hard to get the authentication and authorization right, especially when discussing Kubernetes and cloud native. There are so many buzzwords and jargon, so that's just a fun fact. Cool. So in a nutshell, I'm already giving you the spoiler alert and all of the secrets, so you don't get too bored with long slides. So what we're going to see today is for each of the managed Kubernetes clusters, EKS, GKE, AKS, across AWS, GCP, and Azure correspondingly, how do we choose the right solution and I will explain why this is right. And it's not just an opinion, it's after research. What is the right approach in order to provision access to the control plane? Okay. And finally, we're going to touch on two tangent topics, which are networking and identities. Whenever you talk about control plane access, and even within the cluster, within the data plane, you talk about who is allowed to access. This is the identity and what this persona or service account is allowed to do. And then the next question is from what network? Usually they are lumped together. Let's get started. Maybe just a quick word about cloud native security. When we think about cloud native security, it's not just Kubernetes. We also have workloads running on AWS Lambda, and we also have AWS App Runner, and we have workloads running on ECS. So there is more than one way to run code today on the cloud. And of course, we also have a Google Cloud Run, etc., etc. Now, when we think about how do I protect my environment, it's very challenging because it's never one thing that keeps you protected. It's a multifaceted problem, and we need to apply defense in depth principles in order to secure the code that is running on our environment. The way to think about this threat model is the 4 C's, which is the cloud, the cluster, the container, and the code. So it's like sort of a mental model to think about cloud native security. The focus of this talk is only one pillar, which is the identity and access management.
I thought there were going to be the diamonds, 4 C's. Diamonds also get rated in 4 C's, color, quality, and so people can remember that there's 4 C's in this aspect. Very good.
Yeah. Thanks. The main problem that we're tackling, I'm a platform. I'm as part of a platform team, or I'm running a platform team. How can I ensure that each of the personas that access my cluster are accessing it safely and securely? So who are these personas? We have the developers, and we have the platform teams or SREs. And we also have the CI/CD, which, and here there are two approaches. There is the push-based, the traditional CI/CD, like we used to do the things with Jenkins and the other GitHub Actions. And then there's also GitOps and the pull-based approach to pulling images into our cluster. So we're going to ask ourselves how each of these personas are going to access the cluster. Now, for some of you diehard fans of Kubernetes security, you should say, you know what, no one should have access to the cluster except for the agent that is running on the cluster and is pulling the images. If you think about Google scale infrastructure, developers don't do kubectl exec or kubectl get pod. It doesn't exist. You get a snapshot of the environment, and then you can debug offline. So ideally, you are not supposed to access. But in practice, it's very hard to prevent it from teams.
And developers, for the most part, that are learning Kubernetes, they're and a lot of people that watch the live stream platforms, they work with Minikube or Kind in their laptops, right? Where they create a cluster and they have full access. They become cluster admins, basically, right? They become an admin default user. So sometimes they even doesn't know what is their kube config or things like that. They expect. They have the same expectations when in their enterprise when they're interacting with the internal developer platforms. Like, oh, am I going to get the same access to all the Kubernetes clusters like I do in my laptop? And that's not the case, right? And like you mentioned, in production, in enterprise environments, and even highly regulated environments, and even government, the production cluster, there's no human interactions, right? There's no developers logging in. There might be a use case like a common node, like break the glass environment, where you get a session or access for a time period, like a time bomb period, like 1 hour or 2 hours to do something. And like you mentioned, in some cloud providers, they don't even get access. They get a copy, right? A snapshot.
Exactly. Yeah, that's a good point. And there is an abyss between what you learn in the courses when you use the local cluster like Minikube or Kind versus what you see in the big tech companies and even in small to medium businesses that care about their security, or they have to comply with PCI DSS, SOC 2, GDPR, etc., etc. So absolutely, that's a great point. What we're not going to cover today is the data plane security aspects. It's not like they don't matter. It's just that we're focusing on the first part of the equation. Control plane access, as I said, usually you think about two pillars, identities and networking. During identities, people often confuse authentication and authorization. Authentication means who is allowed to access, and authorization means what privilege, once you are authenticated, once you have access, what can you do with your access? Networking usually talks about VPC and subnets and IP-based, or if you are fancy and you implement zero trust, then identities is the new perimeter, right? You may ask yourself, why is this even interesting? So you finish a Kubernetes course and you look at the documentation of Kubernetes and you get so many terminology, X509, static tokens, OIDC, webhooks, ABAC, RBAC. Like, how am I supposed to make sense of what I'm seeing in the documentation and correlate it to real life? I don't know. I have an EKS cluster. So many choices. Like, just give me the TLDR. And when you think about the control plane, some of the attacks, the software supply chain attacks, this is where they begin their journey. If Kubernetes is an API-driven machine that has a database, distributed key value store, etcd, right? Everything goes through the API server. No one goes to etcd except for the control plane, for the API server. And this is the first line of defense. So it's very crucial that you know who is allowed to access. Secondly, you have the inadvertent misconfiguration. Usually when you look at developers, there is so much to learn. You need to learn Go, you need to learn the Linux command line, and then you need to learn your IDE. Now you're telling me that I need to know how to implement AWS IAM roles and the least privilege. I will deal with this security thing later, right? This is like the last famous words of every developer and platform teams. And it's very concerning because it's hard to get it right. So it's important to appreciate what can we do about it. Now, when we think finally about availability and DDoS attacks, then, well, if you expose your control plane publicly, then some people are allowed to attack your network. So this is something that you would want to avoid. Maybe I should move to a different place. Does everyone hear? Yeah, do you hear some noise?
There's some background noise. You can tell them to keep it down. You should be okay.
How about,
unless you have a room that you can move into?
Yeah, can you hear me better? I switched the. Oh, I'm sorry, Bose.
Yeah, go ahead. Go ahead.
Give me 1 sec. Yeah. Can you still hear me?
Yeah, we can hear you. Just a little bit of background noise.
Yeah, and just to reinforce what I just mentioned, you open the Kubernetes documentation, the scroll bar is so thin. It's very hard to, and you look at the table of contents, you see the authentication and the authorization, so much to read, I don't have the time. So it is a problem.
And it's something that for some folks to understand, right, that they're not familiar with the space, is that the documentation in here in Kubernetes is something that you can run on premise, right? You can run on a server box. So it's the like the generic or the baseline information for Kubernetes authentication. But when on this episode, we're going to concentrate more on cloud. So when now Kubernetes runs on a cloud provider, now there's an advantage, right? Because those servers are running in a data center where now you can take advantage, like the Kubernetes takes advantage of like that authentication, like that a security posture of like, you can trust that these servers and hardware is running on this environment. So now you have to like you can leverage that authentication, like AIM in all cloud providers, to say that identity is native to that Kubernetes installation versus you're running like Kubernetes on a computer with Linux, right? You don't have something to trust, right? Unless you put a TPM and you have something in, then you need to trust maybe the network. That's all you have, right? In a cloud provider, now you're trusting the cloud provider is running that host. So we need to like bind you to that host.
Exactly. I couldn't have said it better.
So let's take I think you have a first example, right, with the first cloud provider.
Exactly. So if we think about Amazon, and Amazon AWS is doing fantastic things, especially recently with regards to EKS. When you think about the EKS Auto, this is a very cool thing that now you don't even need to think about the node auto scaling and all kinds of add-ons and configuration for the cluster. Recently, AWS launched what is called EKS access entries. The traditional approach to access EKS clusters used to be an aws-auth config map. What it means is that you have a YAML object where you mapped AWS identity and access management entities into Kubernetes entities. So using ARNs in order to map to groups and users. Now, there are a few problems with that. You can get locked within your cluster, and you don't want to do that. And also, it's very clumsy and sometimes messy to deal with. So you want something that is more cloud native, I should say. The way EKS access entries works, and this is what I recommend that you use when you configure new EKS cluster and also existing ones, is that you have this cloud entity, the ARN, AWS IAM user, and you provide authentication. We'll see that in a second how to do that, but we create what is called an access entry. The next step is to associate this access entry with one of 5 predefined policies. So as you can see, and there are more, if you look at the official documentation, you will see a lot more policies, but in a nutshell, these are the policies that you should care about. You have the cluster admin, which is the traditional one that you used to get when you provision a new cluster. And then on the other extreme, you have a view policy, which gives you only a get, read list, watch access. And in between, you have different personas that can do different things.
Yeah, and I happen to be a solutions architect in AWS, and this is what we're recommending to end users to start using access entries and not the config map. And config map, like you mentioned, had some drawbacks, and people logging themselves out from a cluster and not getting in ever, right? Even like the persona that created the cluster was the only one available. But yeah, these are like canned policies that you can use, but you can still use RBAC and groups, right, to manage that. But yeah, the recommendation use access entries, and config map is there for backwards compatibility, but you can migrate to access entry if you have an existing cluster. So that should be done with that. So let's move on to the next step of like getting started. Like somebody's not familiar with creating a cluster and configuring access.
Of course. Yeah, thank you for that. You may see this slide and say, what is EKS Cattle? I'm using Terraform, or I'm using Pulumi as infrastructure as code and configuration management tools, or I'm using Crossplane. It doesn't really matter, okay? What matters are the semantics and the concepts. In this instance, I'm using EKS Cattle, which is very recommended, especially for novices. When you start dipping your toes in the water and you want to provision an EKS cluster, it's not just creating a cluster. There is the subnets, the private and public ones. There is the VPC and the ENI and all of the other low-level cloud resources that are typically associated with this entity. So EKS Cattle is, if you want, the syntactic sugar that creates CloudFormation templates for you and does all the heavy lifting, and you get a very high-level syntax. You see, I'm saying EKS Cattle create cluster. I'm providing the name of the cluster, what kind of nodes do I want, in which region, and I can also optionally specify a config YAML. After we create the cluster, and I'll show it in a second, there is an AWS CLI command that allows me to query and verify what authentication mode my cluster is using. Now, for newly provisioned clusters, you will already get the API and config map, which allows to preserve backward compatibility. So you can use both API and config map, and after you are done, you can switch only to API. This is very useful for migrating existing EKS clusters that already use config map.
Yeah. One point is that you cannot go back to config man, just for the experts out there. Like, but I know something that you don't know. So yeah, you can move to API only, but you cannot go to config man. So just be aware of that. So after you configure this, then what happens?
Awesome. Here, what I'm showing you, I use the config.yaml. I will show you in a second in the demo.
Yep.
I deleted my own cluster admin permissions, and before EKS access entries, you wouldn't even be able to do that out of the box, right from right off the bat. And this is very cool. I can implement least privilege even to myself. And when you think about the bigger picture with AWS, which recently added the ability to delete the root account from organizations. So AWS really cares about your security and implementing least privileges.
So there's a question here. Let's take it. Correct me if I'm wrong. In managed Kubernetes, we won't have access to Kubernetes control plane clusters. They were called in the past master nodes. The things that run etcd, or the things that run the API server in a managed Kubernetes cluster, there's no Linux access. You cannot SSH into it, which is a good thing. Something that you don't have to patch. Like if you don't get access to a Linux system, then that's a good thing, because it's kind of like serverless. I don't have to patch the security of it, right? That's up to the vendor to deal with that. But take into account that you have to take care of the worker nodes. That'll be on your end, that security. And then some cloud providers have different features in that respect. Like aws-auth is something that is new, that we have managed instance that we care of that control. But yeah, there's no Linux access to the API server.
Cool. Thank you for that, Carlos. Here, what I'm showing you is what is the config.yaml that I used. I provided myself full read-only access. So if I do kubectl get pod or get node, I will be able to get the result. But if I try to run a pod or apply a deployment, I won't be able to do that. So it's a standard YAML file. It uses EKS cattle specific syntax. You can read about it in the official docs.
Yeah, and they can see the one of the mapping here, like Ofir the user known in the AI, in the cloud provider, will have this policy. So it's an opt-in. You have to opt in to start getting access, where like in the past, you were creating a cluster and you became super user. So now it's a better security model of like starting with no access, and then you start like adding access as you need.
Exactly. And if you want to change after cluster provisioning the existing permissions, then you can specify the config.yaml that I just showed you and run this command, eks create access entry. And what it will do is now it will allow me to list the pods. And as you can see on the bottom, I try to run a pod, but I use the policy that doesn't allow to create resources. So I'm forbidden from actually doing that. In a nutshell, what EKS access entry allows us to do, like what are the pods, what is the TLDR, we get a unified identity provision. And I think this is a killer feature. I can use the same Terraform file that I have. I have Terraform or Pulumi or other cloud native ways to express that. But in just one document, in just one template file, I can express both the AWS permissions and the Kubernetes permissions. So I don't need to go into the Kubernetes API and configure the config map and then do other stuff. I also I avoid getting locked out outside my cluster. It's very easy to just shoot yourself in the foot if you misconfigure aws-auth config map. So no worries about that. I can apply conditional policies. I can use the trust policies and all the goodies that I get from AWS IAM policies using this approach. And I can apply the least privilege on steroids. So as Carlos mentioned, you can delete the default persona that created the cluster. You see this access config bootstrap. It's just a fancy way of saying, I don't want admin permissions for the creator. So it's a very cool feature. And finally, you also have better auditing and multi-factor authentication enforcement. Carlos, you want to add anything on top of that?
No, I think this is we talk about the benefits of using access entry And for people that are using this for a while, they were getting locked out of their ECAS clusters. That was the most common, and it was very hard to get in. And sometimes we just reach out to AWS if that happens. But now with access entries, now you have a as a admin of the cloud account, you can always like create an AIM and give yourself access to like fix things. And we have a question here. So I think people were a little bit confused from the YAML that you were showing before. Like, so it's a new CRD that you can use to give permissions. I think it looks like a CRD, like but it's a configuration for the CLI. It has an API version and kind, so you can guess that it's using Kubernetes Go is using Go to parse this. But that's something that is very common. I think I see that in on multiple, even things like Backstage that we have covered here. And I myself give that recommendation is if you have configuration files that are going to be like JSON or YAML, it's always good to have that metadata kind of API version, just in case you want to create a Kubernetes CRD, a controller in the future, right? That you have that opportunity. But in this case, it's an input file, a config file to the CLI of this cloud provider. So good question, good catch.
Thank you. I'm just being conscious of time, so I'll have to go on some of the slides, go over real quick. You may ask yourself, how does it work under the hood? So after you run EKS cattle create cluster or use the AWS CLI, you usually have the automatic update of your local kube config. And for existing cluster, you can do AWS EKS update kube config. And what happens is that the CLI merges a new entry into your kube config file. What you see here is a kubectl exec plugin. You see the command AWS IAM authenticator. This is a very cool approach that allows the kubectl tool to call an API, to call actually a binary executable and say, I want a short-lived ephemeral scope token. So you get a token from the AWS API after you are authenticated. And this is the key thing. You're authenticated with your AWS SSO or service account, and now you can capitalize on that and obtain a short-lived token to access ad hoc the Kubernetes cluster.
Yeah, this is different. You can go back to that. For folks that are using Minikube or Kind, right? The kube config will have like the insertion of a client certificate and a CA that you connect to that server. But in cloud providers, basically the kube config is just leveraging a CLI that is sitting in your computer, and then that CLI is using your computer environment. It could be environment variables, it could be taking you to a web page, or it could be you can also we have in EKS, we also, you can use here the EKS CLI to interact with the cloud provider and exchange and get that token back, that AIM, that AWS cloud provider token, and that's the token that you sent to the API server. So something that you can leverage from the kube client, and then the kube client is the one that is in charge of refreshing it.
Exactly. And then on the server side, you might ask yourself, okay, so I obtain a token from the AWS API, from the cloud and not from Kubernetes, but what do I do with this API token? So the answer is that you do nothing. AWS got it covered for you. Or the AWS YAM Authenticator, which is, by the way, an open source project, also has a server-side component. So as far as kubectl goes, this is an opaque token. It doesn't know what this token, and it shouldn't even open it. It could be a JOT, it doesn't matter. The server side, when API server receives the bearer token, it goes into a webhook and then asks AWS YAM Authenticator, hey, what is this entity? I don't know. So you need to map the role similar to what we did in the aws-auth config map in the past. And we also need to understand whether this persona is authorized to do the specific action. So Kubernetes API server has this pipeline where it does all these things. AKS, it's a little bit, it could be more challenging. When you go to the blade, you go to Azure portal and you click on create new AKS clusters, you are faced with 3 different options. It's hard to see, it might be challenging to see it the text is a little bit small, but essentially you have the local accounts with Kubernetes RBAC, which I'll explain in a second what it means. You also have Microsoft Entra ID with Kubernetes RBAC and Azure RBAC. The TLDR, you should opt for the third option and not the default one that is selected on some of the SKUs. Let me explain. The first default option for, at least for development clusters, under the hood, it uses an X509. As Carlos previously mentioned, when you have a Minikube or a kind cluster, you will see in the kubeconfig file a very long client certificate. So there is more than one way to authenticate against an API server. This is not something that you want for managed clusters. Of course, for local games and local experiments and local hacking, sure, why not? But for production, even for development and staging, you should avoid the local accounts because it never gets rotated. The last option from the authentication method allows you to do essentially the equivalent to what we just saw with AWS CKS, access entries, access policies. You have one API, which is the cloud provider, a unified API to provision both the authentication and authorization. And it uses the similar approach with kublogin rather than AWS YAM Authenticator. One thing that you should note is when you look at the official documentation of the cloud provider, they say this option provides a non-auditable backdoor option. So this is very scary when you think about it. The cloud provider provides you with means to take a rope and then hang the rope around your neck and commit suicide. So you should avoid this option at all costs. What can you do about it? Azure has a very cool feature called Azure Policy, which is like if you are familiar with admission controllers for Kubernetes, that they are the gatekeeper. They are like the antivirus, if you want, for Kubernetes. You have an equivalent policy engine for Azure, a managed one, and you are able to prevent any cluster creation using this authentication method. So as platform teams and security ops and CISOs, I can ensure that my environment complies with only allowed authentication methods, which is very, very cool. This is how
one advice that you give also, like, is applicable to any cloud provider or any solution or SaaS that you use out there, is it's very difficult to select defaults. Like the same way for developers, it's very difficult to name variables. So you want to have something that is easy for the person that just wants to learn. Let's say just learn. You don't have even a business that you want to get skilled. But at the same time, you want to make it secure by default. So it means like no one has access. So it's a trade-off. So I think the best practice here is, never trust the default. I mean, as a security team, you are in the security team, like we set the standards, right? The platform team will set the standards, will set the guardrails for their platform that they're building. So they never assume that the defaults are like the right choice, because the defaults were thinking maybe on making it easy to get started, but not secure by default. So it depends where you are. So I think that the best way is for the platform team to evaluate and always be explicit. I think that's maybe the second best practice of never leave something on implicit, because what happens in 3 years from now, they decide we want to change the defaults because it's not an API, it's just configuration. So always be explicit and never trust the default. Like, be explicit. What is the actual configuration that you want in each environment, dev, stage, and production?
Exactly. Yeah, secure defaults is a real pain. I will skip over to GKE. This is the last part of the slides. This is the last managed Kubernetes cloud provider that we're going to cover. So when I go to the Google console, I click on create new cluster. Things are a bit easier here. There is one checkbox that if you're using the ClickOps approach of opening the portal and not Terraform, then there is a checkbox that says issue a client certificate. Avoid having this selected. Google provides the equivalent to EKS access entries, or the last option that we saw with Azure Entra ID. It works in the similar fashion in terms of provisioning the authentication authorization. Now, the last point that we want to think about is networking, right? I mean, we talked about identities. We talked about how to how to safely and have a unified API for provisioning identities. But we should also ask ourselves, is the networking that the CI/CD connecting from, or the developers working from a coffee shop, is it a trusted network? I don't know. So typical approaches, the DIY approach, is to bring up a Bastion host that has a public-facing network interface and private-facing, and then you have an SSH key. You SSH to the Bastion. It's a hardened machine, and from there you can access the cluster. Another approach is to use an identity-aware proxy, which is more or less equivalent to that. It's just a more advanced proxy in the sense that it is aware of identities. So it verifies that you are authenticated against the cloud provider. But it's just shifting the problem away, because now we also have SSH keys that never get rotated. And it's very hard to bring up a Bastion host, and it's very easy to get things wrong. What Google did, and by the way, I highly suggest to follow Greg Castle from the GK Security Tech Lead team. He's very professional and adept at GKE, Kubernetes security-related issues. They created a new approach that essentially brings zero trust to Kubernetes. So what it does, in a nutshell, they expose, GCP exposes a new public frontend. So it's similar to an identity-aware proxy, but you can access even from on-premises or even from remote location. You can make your cluster endpoint private and still have a front end that is publicly facing. Now you may say, wait, so this is cheating. I have my private cluster, but I can access it from anywhere in the world. Well, no, because identity is the new perimeter, right? You have a front end, a public-facing front end that verifies the identity. So rather than setting up bastions and configuring reverse tunnels and managing keys, someone else already solved it for you. So this is super, super exciting. The way to enable it is you go to the cluster
But
settings.
you still have the DoD problem, the denial of service problems? Or is that something that you don't have to care about?
Yeah, that's a great question. That's the beauty of managed services. So Google already took care of it for you. You have like this equivalent to WAF on GKE. So they already care of DDoS attacks.
Right.
This is how you enable it. You can, by the way, this will be recorded and you will be able to review the slides offline. So don't worry if you missed anything. We can jump to the demo. I just want to say, yeah, let me share my screen.
But to summarize a little bit here is every cloud provider, like when you're working, we're accessing that Kubernetes cluster on any of the cloud providers, kubectl, we usually will have a plugin, we have a CLI, that command, and then that command would authenticate you with the AIM. It could be GCE EIM, it could be EKS EIM, and then you are like authenticating because your laptop, right, where you're sitting, you have to be AIM, you have to have the access keys. Hopefully you don't have access keys, right? Because that beats the purpose of like getting a temporary token for your kubectl, but it's using a permanent key that is in your laptop that never expires. So we go back to like, you have to go to the next level of like, while you're telling your developers to set up their laptops, to also authenticate to that cloud provider to get a temporary access, right? It could be a single sign-on from the cloud. All cloud providers provide a single sign-on to the AIM, or configure the cloud provider to trust an OIDC or an AD that then you as a human being with your laptop, and it could be also, I have one in my laptop, like a key, right? A physical key where I have to touch, that I should not be losing that key. But it's that the double authentication, right? 2FA
Exactly.
also to do that. And then sometimes that's what the platform teams misses. It's like, we already configure that, like, let the developer authenticate with their identity, but they have to, I think, do better in terms of adoption and security. Make sure that that laptop and that developer has the 2FA, that your cloud only allows 2FA. It could be like some cloud providers, you can, like, let's say, I only, if somebody's logging in as Carlos, MFA, right? Or 2FA, multi-factor authentication. So you can get a temporary token. kubectl will get that temporary token, and then connect with that token of the cloud provider, and then exchange for access, where each is RBAC or access entry. So I think that's the summary that I think a lot of people may not be aware of. Like, well, I kubectl minikube, how do I work when it's a cloud provider? I think you show that the three are common on that, and also not trusting default settings or never allow a certificate, long-lived certificate. So yeah, so let's move on to see some action.
Okay, let me share my screen. Okay, what I'm going to show you today is I just show you the slides, but before this demo, I provisioned an EKS cluster. I called it, everyone can see my screen, right?
Yep, we can see it, dev cluster.
I have a cluster called dev cluster, very cool name. I go to the access tab, and this is the important thing. If you open each of your EKS clusters, at the very least, you expect to see either EKS API and config map or just EKS API.
And then that would enable access entries. Like, that's a requirement.
Exactly. And here you can see the list of the authorized entities. For example, I allowed myself access. And on the right hand, you can see in the access policy column what this persona is allowed to do. So it's very easy, rather than having a config map that you now need to do kubectl, you need to download another tool. You have a single pane of glass for authentication and authorization, also for Kubernetes. Now, to show how it looks like, as Carlos previously mentioned, after we create the cluster, what you get, let me scroll down. I look for EKS. This is called a kubectl exec plugin. This is the command that we showed in the slides. As you can see, we are moving several parameters, like the token and the name of the clusters, and this will fetch the ephemeral cluster from the AWS. Kubectl get pod. I can list the pod, and as I mentioned, I didn't provide access, even though I created the cluster. I didn't provide myself any access to do modifications, so I'm just not allowed to do it. Very cool. Maybe one last thing that I should mention. In this session, we only covered like the tip of the iceberg. Carlos mentioned that Kubernetes does not have any secure defaults whatsoever, right? It's hard to get it right across clouds. So you need to remember that it's not just the identities that you need to care about. I don't want you to live with this notion that, okay, now I have EKS access entries, I can go home and just relax and rest on the laurels. It doesn't work like that. Kubernetes security is a multifaceted problem. Keeping up with what is changing is very, very hard. This is why you should use, as platform teams, tools and automation, and you need to have vendors that you trust or open source that you trust. And you need to think about, you need to challenge yourself into VPNs or ZTNA networks, and how do I implement least privilege? And the best thing is to just fail and try. Just don't do it in production. So as Meta says, move fast and break things. This is what they have on the in the offices. Just do it securely and also responsibly. Finally, I invite you to connect with me on LinkedIn if you want, of course. But we published in Wiz a security report of the interesting trends that we see in production, like common types of attacks and how to avoid them. So I highly suggest that you scan this QR code and follow us. Carlos, is there anything else that you wanted to perhaps cover on the EKS?
Yeah, I think we can cover one more question. Guy, I think there's a question about our role bindings and GitOps. Interesting.
Okay.
Because if you want to create a specific RBAC role for a group, you will need to create a role and a role binding. And then there was another one on the GitOps approach. And would you add it to your GitOps approach? So one good thing, like you mentioned, like the differences. Like we talk here about the differences between the cloud providers. That's a good thing. That is only this, because what we showed you was the diff, but what we didn't show you was the commonalities. So your RBAC configuration where, for example, if Offer and Carlos are in the sneaker team, we can use 3 cloud providers, but your RBAC configuration, your roles, what do I have access, which namespaces I am, and which group we are, that is YAML that you can put in GitOps, right? We can use Flux and Argo CD and deploy it to the 3 clusters, and that will be common. Like you have namespaces, maybe you have the same namespace in the 3 cloud providers, the same name of the group, the same row and row bindings or cluster row bindings, and the difference is that when I'm going to log in into one cloud provider, like maybe I use EKS, I am Carlos there. If I use another cloud provider, maybe I'm Carlos with an email address on an AD, but your team will configure your claims that you're claiming that Carlos is part of the sneaker team and Offer is part of the sneaker team. All that YAML, GitOps in Git, will be common across all your clusters, right? Dev staging across cloud providers. So that's kind of also the benefit of using Kubernetes, that part of the configuration, which is very large, is going to be common across the different environments, even on premise, right? If I have a home lab like I have here with some Jetsons and Nukes and Raspberry Pis, I can create a group called the sneaker team. I have namespace at the same thing, and same configuration goes into my home lab, and I authenticate there, maybe with something like Keycloak, right? CNCF project that offers an OIDC implementation to authenticate there, or authenticate with GitHub, right? GitHub offers a way to authenticate yourself as you're being part of an org. So that's very good. So I think that was a good episode to show people like we always talk about the commonalities, but it's also good to talk about the specifics. Like depending where you're running, you have to have specifics because you want to trust that environment where the service that you're paying for is trusted. So thank you, Offer, for your time today, spending our time and also like doing the research of the differences between the different cloud providers and also best practices, right? In your space, I think you're learning about a lot of incidents and such. So I ask people to follow Offer on LinkedIn. He posts and reposts a lot of like content around container security, and that's how I keep up on container security also. So, and I invite you to our next episode. Check out our LinkedIn page. Join the page. We just hit 2,000 followers in our LinkedIn page and platform community, and we have new hosts joining and helping us drive these platforms live stream. So, great. Thank you for the people that joined. And if you watch this online, go back to LinkedIn or YouTube and put a comment saying that you enjoyed it. So, thank you so much. See you, folks.
Thanks you for having me.